Good afternoon to everybody. I'm happy to greet all the participants of the International Conference on Mathematics, Science and Technology Education. I'm Professor Liudmyla Gryzun, and I'm happy to represent here Information System Department of Simon Kuznets National University of Economics, Kharkiv, Ukraine. And also, I am happy to introduce my co-author, Professor Liudmyla Bilousova, independent researcher from Kharkiv, Ukraine. The topic of our presentation today is the issues of design of a Petri net-based software component for modeling holistic and coordinated curriculum for potential specialist training. The outline of our presentation includes the problems of building holistic and coordinated university curriculum, the author's approach to the curriculum modeling using Petri nets facilities, which makes the theoretical framework of our work, and to cover the issues and the stages of design of the Petri nets-based software component for the holistic and coordinated curriculum building and modeling the process of its mastering. So, in terms of the urgency of the research, the problems of building holistic and coordinated university curriculum are caused by the number of factors which demand the search of new approaches to the curriculum building. So, among these factors, we can outline, for example, quick changes and renewing of technologies, social life situation in labor market, etc. Also, these processes are caused by the international students and employees' mobility, which in turn causes international context of higher education. So growth of information amount, knowledge expansion, renewing of knowledge, losing its urgency very quickly, also causes the necessity to find out new ways how to build curriculum for students' training. Trends in contemporary scientific branches also have the signs of synthesis of knowledge, mutual enrichment, interdisciplinarity, and interdisciplinary research with mutual interpenetration of knowledge and cognitive methods, tools, and so on, which also must be taken into account. So all these tendencies, which I have talked about, must be reflected in the content of training of university students, because global science and employment market demand specialists who are ready to solve integral problems, have flexible system of knowledge, are able to use it in related branches, and are able to adapt quickly to different changes, retraining, reorientation, and so on. So, in terms of university curriculum building, it's also important to understand that curriculum disciplines or educational components have, I would say, double function. On the one hand, they are implementation of certain educational content, and on the other hand, each curriculum discipline is embodiment of some scientific branch adapted to teaching and learning. Hence, it must reflect correctly the branch structure, preserving main links between notions, concepts, factories, theories, and so on, which really exist inside of scientific branch and between sciences in the whole. So, important pillars as the guidelines for curriculum building in university education include the following. The curriculum, contemporary and modern curriculum, has to preserve the concept of computing throughout the world and in time, as well as to support existing, emerging, and future computing disciplines, both for the today and potential students, which is incredibly important exactly for IT specialist training. It also has to mind future trends and achievements and be flexible to get global enduring acceptance and the adaptability with the multiple educational contexts. So the main problems which are to be solved, they are the following: how to form integrative content of learning, how to provide modular structuring of curriculum disciplines with preserving links between knowledge, and how to provide the coordinated learning throughout the modules of different curriculum disciplines for per-service specialist training. So it's necessary to develop some alternative approaches to the curriculum design based on mathematical and digital tools, which are able, first of all, to overcome the exposed problems, to cultivate cross-disciplinary strategies of teaching and learning, and to form students' holistic, coherent, and flexible system of knowledge. Thus, the purpose of our work is to elaborate some stages of design of Petri net-based software component for the holistic and coordinated curriculum, and to cover some benefits for the per-service IT specialists at their vocational training exactly. So, the theoretical framework of the work is made by the holistic educational paradigm and also by the author's approach to the modeling of holistic and coordinated curriculum based on knowledge representation models and Petri net operators. So, in order to cover in brief and characterize in brief our approach to curriculum design, I'd like to highlight some key characteristics of this approach and cover it as a theoretical basis for our current research. First of all, it is based on the revealed mechanisms of knowledge integration in scientific branches and in curriculum disciplines. It provides technique of discipline structure, which triggers the integration mechanisms realization. And finally, it results in the coordinated system of curriculum disciplines, which can preserve links between knowledge and make positive impact on the trainees' system of knowledge. So the technique of discipline structuring in this approach is based on some core ideas. First of all, it's multi-level construction of the content of learning, multi-level knowledge generalization, and models of knowledge representation, which were used as a digital instruments. In particular, we use semantic networks and frame-based systems with their hierarchy and inheritance properties, which are incredibly beneficial for our work in this context. So for core stages of the technique of structuring of disciplines according to this approach to curriculum building covers some core steps or core stages from superdiscipline level, so-called, to the level of the learning activity, And here you can see step-by-step procedures at each of the stages, which step-by-step lead us to the structured disciplines using frame-based knowledge representation. For example, the one of the stages, we obtain hierarchy structure with frames in its nodes, and each frame here corresponds to cycles of training, to curriculum subjects, their modules with their learning elements. And finally, this common structure is filled in with the exact meaning of learning elements. That is the level of so-called learning material, where we fill in the all frames prototypes of previous stage with exact data, exact values of learning elements, exact inheritance pointers for each slot to provide proper links. And finally, we obtain coordinated and coherent system of curriculum subjects, and in formal way, it can be presented as the system of curriculum subject, each of which is presented as a nested system of frames with links between them. And all of the links are provided between learning elements, which are inputs and outputs, and all of these links are provided due to the special properties of frame-based knowledge representation model. The technique to the discipline structure, and which I have described, and coherent curriculum shaping was implemented and verified. However, in the process of real curriculum building, it became clear that it is necessary to elaborate the issue for the grouping learning elements into the frames, which in fact are modules of our disciplines, because it's essential to group them, taking account also the sequence and precedence of their learning within the modules and disciplines, not only links, but also the coordination. It's necessary to coordinate their learning. It will make their mastery not only holistic, but also synchronized and coordinated. So it became clear that we need to use some special mathematical instruments in order to make these modeling coordinated. As a tool, we have used Petri nets apparatus. As it is widely known, Petri net can be defined as a two-partite oriented graph, which consists of two types of vertices, places, which are circles and transitions, and also the places can accommodate tokens, which can move around the net via transition bars. Okay, and exactly this facility allows to model the dynamics of processes. At the preparation stage of modules modeling, we distinguish inputs, which are the learning elements necessary for the students to master in order to be able to learn the learning elements of these exact frames, and in similar way, the outputs can be interpreted regarding the other frames. Then we determined the types of the precedence relations for the inputs and outputs for the frames. And here you can see three types of precedence relations for inputs and two types of precedence relations for the outputs. Based on these precedence relations, we managed to model, to build a Petri net model for the process of learning element mastery. And it is represented by 4 places and 8 transitions. The places represent the states of learning elements as for their readiness to be learned by students due to their relations precedence. And there is always one and only one token. You can see it in place number 4 in the net, which means that only one of these places can be marked at a time. The transitions simulate the events of start of learning elements mastering, the process of its learning regarding the academic time, and its availability due to the precedence relations and accomplishment as well. So, and these basic blocks of which represent the modeling of a learning elements mastering, then we are added together. Net addition is done by merging transitions, also using the precedence relationships and these operations and in OR, which allowed us to model a frame or the course module of the whole course or curriculum disciplines. In similar way, the Petri net representations of 2 modules presented by common Petri nets after applying the rules presented above, using a net addition operation, considering and precedence and or precedence. You can see their middle steps of this stage. So then, using the operations of Petri nets modifications, in particular their fusion and learning elements connections in different times, we could obtain a model for a curriculum discipline module, and finally, a model of curriculum discipline. It is essential to note that output transitions of each learning elements model can trigger the subsequent learning elements model only if the previous, in terms of precedence relation, one is accomplished. It is guaranteed by the rules of Petri execution and modification. And it's clear that this theoretical approach needs to be automatized. The built Petri net allowed to simulate the process to the learning elements mastered by students in the curriculum courses and between them. It facilitates provide grouping learning elements into the modules, taking into account both links between them and precedence of their learning by a trainee. And facilities of frame-based model of knowledge representation provide spreading the links between the learning elements, between the module and between the modules of curriculum discipline. It's clear that all of these advantages will work in a proper way after the automatization. So it became necessary to think over design of a software module for automatization of the Petri nets modeling of the coordinated curriculum. I used such an abbreviation, and here I'm going to cover the main stages and features of design of this module. In terms of functionality, it's clear that we have to detect or determine the functionality of our potential model. It's clear that it will aim to provide the dynamic execution of the simulated processes, and thus the functionality at the exploitation level is focused on the storing the Petri net execution graph, which declares when each task on the certain learning element mastering has to be executed in a static way and also in dynamic way. So the functionality is focused on tracing the tasks already executed, so already learned and mastered learning elements, and obtaining the list of the tasks ready for execution by leaving the Petri net to evolve. And coming from these two core functions, we determine the structure of our software module. It will consist of two main components, so-called task manager and coordinator. And I have to mention that by the task here, we are going to mean a learning element mastering by a student or by a trainee. So the task manager component is aimed at performing the following three tasks, let's say, starting the execution of each task by notifying the coordinator, then detecting when a task accomplishes its execution and notifying the coordinator, and queuing the coordinator for the list of executable tasks. In turn, coordinator component is responsible for managing a data structure, implementing the Petri net execution graph, getting the notification of a task start or to its termination, and evolving the net graph status consequently. So it's clear that these two components are going to be interconnected, and their interaction in terms of dynamic processes is shown here. First, the task manager acquires coordinator for the list of executable tasks, and coordinator checks the status of the net, then provides the task manager with the list of executable tasks. Then this list of tasks is analyzed, and if it is empty, the task manager is waiting for the new executable task. If it's not active, empty, the task manager triggers the execution of each task in the list and notifies coordinator about this. And coordinator also performs its role And finally, the tasks manager waits for the accomplishment of a task and notifies the coordinator about this event. So the interaction of these two components of our software module is going to look like this one, like it is shown in this flowchart. After this determining this interaction mechanisms, we could detect or determine the functionality of coordinator itself. It has to build the Petri net execution graph. It determines the executable tasks and update the graph by forcing its dynamics. Executed a node, terminate a node, freeze, unfreeze, and set an executable node. So we just thought over all of the peculiarities or features of functionality, structure, and design. Based on these requirements, it was built to the thought over the classes architecture, and you can see it here that it includes some basic class Petri nets, which provides all the basic methods to build, run it, manage a Petri net. Class coordinator, which supplies all the methods to manage the build Petri net in terms of executable tasks. And in such a way, the coordinator performs high-level methods for using the Petri net execution graph. And class task manager, which provides the methods to manage the execution of the certain tasks which are available to be executed. So far, we have prepared completely to the next step of the software component development. In terms of the benefits of using a software module for Petri nets modeling of the curriculum, the functionality of such a model will allow both educational staff and the student to trace and explore the process of the curriculum mastering, to see and analyze the place of each learning element in the modules and in the whole curriculum according to its links, to trace the learning elements that have been mastered and will be necessary for mastery other set of learning elements of other disciplines and other modules, to build individual study plan. And besides this software modeling can be used by the educational staff at this stage of the tutoring process to pick up relevant learning and project-driven activities in order to create students' holistic system of knowledge and skills, because it makes obvious the interlinks between learning elements and understand what kind of learning activity will be beneficial in order to keep these links and to provide these links into the students' minds and system of knowledge. And just a bit to accomplish everything, some benefits in terms of exactly IT specialist training. The built and realized model by such a software module enables to simulate the mastering of the university curriculum as a family of disciplines which are really sensitive to the quick changes in volatile IT industry, with immediate spreading of renewed requirements to the specialists in these branches throughout all of the modules, and also to regard the disciplines evolution and appearing new disciplines in this sphere, with their including into the flexible curriculum, with excluding at the same time unnecessary repetition and academic time saving. Thus, it is helpful in terms of individualized IT specialist training and building their personal educational path. Here, that's all. Maybe. Thank you for your attention. I will be happy to answer your questions.